we're going to work out the arc length for the curve defined by a parametric equation where x is equal to 2 cos 2t, y is equal to 2 sine 2t, and t is between 0 and pi on 6. So the formula that we have is L equals the integral between a and b of the square root of dx dt all squared plus dy dt all squared dt. So what do we have? We know a is 0. We know b is pi on 6. We also know x is equal to 2 cos 2t. So if we differentiate that with respect to t, dx dt is equal to minus 4 sine 2t. So we now have dx dt from the formula. We can find dy dt similarly. Y is equal to 2 sine 2t, so dy dt will be 4 cos 2t. So now we can substitute into our formula. The integral from a was 0, to b was pi on 6, square root of dx dt all squared, so minus 4 sine 2t all squared plus 4 cos 2t all squared dt. Okay, squaring minus 4 sine 2t, I get 16 sine squared 2t. Squaring 4 cos 2t, I get 16 cos squared 2t. So now we can look to see what we can do. 16 is a common factor. So we have the integral from 0 to pi on 6. I'm going to take 16 out as a common factor, and that will give me, inside the bracket, sine squared 2t plus cos squared 2t. Now, that tells us we have a 16, but sine squared 2t plus cos squared 2t is 1. 16 times 1 is 16. So there's nothing for us to do there, except for the right 16 equals the integral from 0 to pi on 6. The square root of 16 is 4. Now when we anti-differentiate 4, we will get 4t between pi on 6 and 0. So L will equal, substitute in the pi on 6, I get 4 times pi on 6, minus, substitute in the 0, I get 4 times 0. So that is going to give me 2 pi on 3.